Welcome to Mimi's Math channel. Today I will be discussing using the TI-84 Plus calculator and Desmos when graphing quadratics. So from my first example, I have x squared minus 3x minus 4. So what I want to do is put this in a calculator, and then we're going to try to find the key characteristics of the graph. The first thing you want to do is select the y equals button. And for your x, it's the button that's next to the alpha, x squared, and now minus 3x minus 4. Once I have the function entered or the equation entered, go to second and then trace because we want to calculate. So whatever's in blue, we have to hit second first. I'm just going to talk about the first four from the calculate menu. That will help us to determine what we're going to write down. For the first one, it's already selected, so I'm just going to hit enter. This is where I want to find my y-intercept. So x has to equal 0. So I'm going to type in 0. And once I press enter, it tells me what my y-intercept is. It's going to be 0, comma, negative 4. In my class, I want the x-intercepts and the y-intercepts to be written as an ordered pair. I'm going to go back to second trace, and I'm going to go to number 2. Well, number 2 says 0, but remember, another name for 0 is x-intercept, solution, and also root. What that means is, where does my graph cross my x-axis? So I notice at 2 places it's crossing. So that means I'm going to have to do the second trace 2 times. Well, the first time I want to try to figure out this 0. In order to do so, I'm following my directions in the bottom left-hand corner of my calculator screen. It asks me to go left bound. I'm using my x-axis. Well, if this is the point that I'm trying to find, what's to the left of it is really going up. But I am only using my left and my right arrows because that's what the wording says. So I'm going to move to the left above what I'm looking for, anywhere above. Hit enter, and then it says right bound. So now I want to move to the right. And again, I'm looking at my x-axis. So the graph is going to the right. So I want to move past what I'm looking for, which is at 0, anywhere past it, hit enter 2 times. This tells me what my 0 is, or my x-intercept. Negative 1, 0. I have 2. Going back to my calculator, I'm going to try to find this one. So I have to go to second, trace, hit number 2, or you can arrow down. This time to the left of what I'm trying to find, I have to move over. I like to go past the vertex, but you can go anywhere. So this is good enough. Hit enter. And now it says go to the right of what I'm looking for. So I want to keep going. Anywhere up there, hit enter 2 times. And now my other 0 is 4, 0. Well, we already knew the y was going to be 0. Now, what I do want to bring to your attention is sometimes the y will show something like a scientific notation, maybe like 1e to the negative 12th power. Well, that still means 0 because, let me write it out. If I saw something that said 1e negative 12, what this is telling me is to take my decimal and move it back to the left because it says negative 12 places. So 1 has a decimal right here, but if I moved it back 1, 2, 3, 4, 5, well, 12 times, and I put 0 placeholders, that number is still the same as 0. All right, so looking at my function, I see that a is positive, which tells me that I'm going to have a minimum. So my graph is going to look like this because positive, just think of a smile. If it were negative, like a negative x, then that would look like a frown and I would have a maximum. But that's not the case for this particular example. I know I'm looking for minimum. When I go back to my calculator, I am going to choose number 3. When I choose number 3, the minimum is my vertex, really. So I'm going to follow the directions, which ask me to go to the left of what I'm looking for. So using my left and right arrows only, I'm going to go past what I'm looking for, anywhere past it, and hit enter, and then anywhere to the right past what I'm looking for, and I'm going to hit enter 2 times. Not only does it tell me that this is a minimum, this is my vertex. So my vertex, and I'm going to round it to the hundreds, which is 2 places after the decimal, since I see that's how my y looks. I'm going to put this in a set of parentheses as 1.50, negative 6.25 as my vertex. The vertex tells you a lot of information. So like my x value is actually my axis of symmetry. I know that because axis has an x in it. So x is equal to 1.50. And what that means on the graph is that at 1.50, if I were to draw a dashed line here, that is going to create symmetry where I can fold that parabola onto itself. Now, the next part is my minimum, and my minimum tells me my y value. I'm going to circle minimum, and I'm going to label it as y is equal to negative 6.25. So if I'm looking at my vertex, I see that my vertex and my axis of symmetry have the same value, and my minimum or my maximum, depending on my problem, is the same as my y value for my vertex. If I wanted to find my interval of increase and decrease, I would take my finger, pen, or whatever I have, and I would trace it. You always have to account for negative infinity to positive infinity. If I'm talking about intervals, it's always my x values. So if I took this graph and I stretched it out to the left, it's actually coming from my negative infinity side. So what's going on? If I'm tracing it with my finger, pen, or whatever I have, I'm going down, I'm decreasing. So I'm decreasing from negative infinity to whatever this x value is, because again, intervals mean your x values. So I'm going to write for the interval of decrease, parentheses, negative infinity, and then whatever my x value was for my vertex. If I know my vertex, I can fill out a lot of stuff. So now for my interval of increase, well, if I decrease down to 1.5, guess what? I'm going to increase from 1.5 to positive infinity. So let's go look at the graph. So I decreased and I stopped, and now I'm going to increase. So 1.5 all the way to positive infinity, because positive infinity represents going to the right. My positive interval means when the graph is above the x-axis, and my negative interval means when it's below the x-axis. I always have to account for my negative infinity to my positive infinity. If I were to take this graph and stretch it out from left to right, I am actually starting from negative infinity, and it keeps going until it hits this point. Well, this is -1, but guess what? It's also positive over here. So I would put a union sign in between, and I would write 4 to positive infinity. In terms of the negative interval, the graph is negative between -1 and 4. For my positive and negative intervals, I have to account for my negative infinity and my positive infinity. In terms of my numbers, they have to overlap. So -1, -1, 4, 4. I know that I'm done. In terms of above here, I notice I'm constantly using this 1.50 and this -6.25. All of my x values are going to be in purple, and my y values from my vertex, I'm using those. End behavior is just basically asking what's happening to the ends of your graph. If I have a minimum, it's going to always be positive infinity for my y's. Both arrows are pointing in the same direction. So basically what it is saying is, as x is approaching negative infinity, f of x, which means y, is approaching what? As x is approaching positive infinity, f of x is approaching what? If I'm right here and I'm walking, and now I look which way? I looked up. That's positive infinity. If I'm here and I'm walking and I look up to that arrow that's closest to me, which way am I looking? To positive infinity. Each time that I have a minimum, then my f of x for my end behavior will be positive infinity. That was how you use your TI-84 plus. So now what we want to do is take the same information and verify it in Desmos. So I'm going to go over to Desmos. I've already typed in the function, and this is what the graph looks like. This one is pretty easy, because if you wanted to find your vertex, you just click on your minimum. So if I clicked here, it tells me that my vertex is 1.5. I wrote it as 1.50 and -6.25. That's what we wrote, right? My axis of symmetry is always whatever the vertex x portion is, and my max or my minimum is always the y portion. Same thing here. So my x would be at this 1.5. You can't really see it, but there's a 1 here, and then this is 0.5. And then, of course, your y is -6. And then if you go down in between, somewhere around here, it's -6.25. In terms of my interval of increase, again, I'm only looking at my x values, and I'm tracing it. So from this point of my x, 1.5, I'm going up, which really is going to the right, because these are my x values. So I'm going towards positive infinity. In terms of my decreasing, I'm taking this, stretching it out to the left. So negative infinity all the way to whatever this x value was, which we already know is 1.5. So that's where I got this information from. Then if I wanted to find my x-intercepts, I just simply click on it in Desmos, and it tells me -1 and 0, 4 and 0, which is what we wrote down. Okay, so for my y-intercept, that's going to be where my graph crosses my y-axis. So that's 0, -4. See how it's written as coordinate? That's how I want it. My positive interval is where it is above the x-axis, and I am going to separate that with a union sign. You learn that in geometry. So from negative infinity to -1, your graph is positive. From 4 to positive infinity, your graph is positive. The graph falls beneath the x-axis and is considered negative between the points of -1 and 4, which is what we wrote. All of these will have parentheses. I know what I'm missing that I did not say on here, so I'm going to go ahead and add that, which is my domain and my range. All right, but before I do that, let me finish with my thoughts. In behavior, as x is going towards negative infinity, y, you're following your arrow, is going to positive infinity. As x is going towards positive infinity, y is again going towards positive infinity. Domain, since there are arrows here, you can't see it because it goes on forever. That means that all of these x values can fit within this graph. So therefore, my domain is going to be all real numbers. So you can say x is all real numbers, or you can just write it as negative infinity to positive infinity, or you can just write the words all real numbers. For my range, that's going to be all of my y values that can fit inside of this graph. There is a stopping point here. So when I'm reading my graph, I either read from left to right or from bottom to top. The bottom, up and down, that's my y value. The lowest point that I have is -6.25. So every y value after that or above that can go inside of my range. So I can write my range as bracket -6.25. This side will be a parentheses. Or I could say y is everything that's greater than or equal to -6.25. You will notice the y value looks familiar, doesn't it? So that's the end of this video. Please like and subscribe. Have an awesome day.